Alright y'all, so as promised, here is a video that's going to help with calculating wavelength and frequency. As you can see here on our left hand side, this is what you have in your notes. This triangle is going to help us figure out how to manipulate our equation based on what variables are in the problem. So here on top we have C. This is reflective of the speed of light. So everything on our electromagnetic spectrum is traveling at the same speed. That speed is 3.0 times 10 to the 8 meters per second, or meters second negative 1. And again, this negative 1 is coming from taking the second out of the denominator here and bringing it to the top. Okay, and that makes it really helpful and useful for us when we're trying to cancel out units later. So I like to use this one more. Here we have the Greek letter lambda, which is representing wavelength. Wavelength can be measured, it's typically, if you look at the spectrum, measured in nanometers, but you might also see it measured in meters. And again, that's just a metric conversion. If you have 1 nanometer, that's equivalent to 1 times 10 to the negative 9 meters. And then 1 meter, of course, is the opposite. It's equal to 1 times 10 to the 9 nanometers. And then we finally have frequency. Frequency, this is the Greek letter nu, but it kind of looks like a V. It's measured in hertz or seconds negative 1. And I like to use this one a lot because, as you can see, it's something we can cancel later. If we're looking at this pyramid right here, the way that we use this pyramid, whatever we're trying to solve for, so for example, even though speed of light's a constant, the speed of light, c, would be equal to wavelength times the frequency. If I were searching for wavelength, I would take the speed of light and divide it by the frequency. And then, if I was looking for frequency, speed of light divided by wavelength. Okay, and that's because wavelength and frequency, we can do this because these are an inverse relationship. So as one gets bigger, the other gets smaller. So let's look at this problem. It says calculate the wavelength of radiation emitted from a radioactive cobalt with a frequency of 2.80 times 10 to the 20th seconds negative 1. And again, it wants my answer in units of nanometers. Okay, so speed of light is always given to me. It's a constant. It never changes. So it will never be, even though it's not mentioned in the problem, it's because it's always the same number. So we already know this. We can go ahead and fill this out. But wavelength. It says calculate the wavelength. And again, I don't see the units anywhere else. That's what it's asking me to find. Okay, and it's giving me this right here, 2.80 times 10 to the 20th. S negative 1. Okay, so I already know that I'm going to have to do some conversions just because I know that my units are in nanometers, and here I have meters. But let's just go ahead and set up the equation first. If I'm looking for wavelength, which is here, I'm going to take the speed of light. My little dinosaur right there. Sorry, Lambda. And we're going to divide it by the frequency. Alright, so units are so important in these kinds of problems. And we've set it up nice and neat like this. So we can already see right here, we have S negative 1 in both the numerator and the denominator. So this unit's going to cancel, which is good. The only unit that I have left, though, is meter, which is why I know I'm going to have to do a conversion eventually. So this right here, if you have the same base, right? Same base, these exponents I can subtract. Okay, so you can do it a couple of ways. You can either say 8 minus 20, and that will give me the negative 12, or you can just say this, take away 8 from it, this becomes 12, and this right here completely goes away. Okay, so this would look like okay. So now from this point, we just have to divide. So we're going to take this hopefully y'all can see this calculator. So we're going to say 3 divided by 2.80 times 10 to the 12th. Okay, and so I'm going to see here. So I'm going to take it to the second decimal place. And do not forget this over here. Okay, times 10 to the negative 12. Again, my meter did not cancel. Okay, but it wants it in units of nanometers. So we have to convert from meters to nanometers. And this is just a little bit of dimensional analysis. We do a lot of this, especially in stoichiometry. But my goal is I want my units to cancel, okay? So if I look at these two here, if I have meter on top, I want meter on bottom here so that it would cancel out. Just like our seconds up here, we had one on top and one on bottom, and so they canceled. Same thing here. So I'm going to say 1 meter is equivalent okay, so on bottom is always what you're trying to get rid of. On top is what you're trying to go towards. So this, when I am multiplying, and again, same base, when we divided, we subtracted, here we can add. So all I gotta do, negative 12 plus 9 and this would be my final answer. Okay, so this problem says calculate the frequency of radiation with a wavelength of 442 nanometers. Okay, so let's just go ahead and fill in what we have. We always have speed of light, it's a constant. It's asking us to calculate the frequency and our wavelength. Okay, again, I want to look at units. See if there's anything I'm going to need to convert that would make my life easier. Here, do you see how there's a meter here and a nanometer here? I'm going to have to convert this into meters, okay? And that's just so they play nice with each other. My units cancel out. Let's go ahead and set up our equation. If I'm looking for frequency, I'm going to take speed of light divided by wavelength. Again, you'll notice that's very similar to what we just did. Okay, so frequency equals and again, this right here, that's not going to cancel. So let's go ahead and convert this to meters before we plug it in. Okay? So 442 nanometers. Okay, in the previous problem, if you remember, we had meters and we wanted to convert to nanometers. So we had meters on bottom, nanometers on top. This is the opposite. We have nanometers, we want meters. Okay, so nanometers is going to have to be at the bottom, and meters is going to have to be on top. Okay, so 1 nanometer is equivalent to 10 to the negative 9 meters. Okay, we're going to plug this in so I can see here. Nanometers will cancel, which is good. All I'm going to do is this times this. Okay, and just so you can see it in a calculator, if you're really good with decimal work and you know how to move this and change, you're okay, go ahead and do your thing. But just so the people can see it, 442, and then times 10. Okay. So we see here, so all we're doing really, to put it in scientific notation, is move the decimal twice to the left. So now we're going to take this and we're going to plug it in, because now it's going to play nice and I'm going to see. Perfect. This makes our life a lot easier. We have meters canceling. So the unit that I'm left with is S-1, which is good because that's what frequency is going to be measured in. Okay, so I have 10 to the 8 here minus a -7. So that means this is going to change to again, when we combined these bases like this, okay, these go away. So this becomes a positive right here on top. When I divide this out, sorry, I like more to my screen. One round to the seconds, this become a 9. Make sure you don't forget this. There you go.